Namaskar, welcome to Exercise Explained. In this video, I would be doing exercise 7C, Reflection of Light, ICSE 9th Physics. I have done the previous questions in separate videos, the link for which will be there in the description below. Do check them out. For understanding these questions properly, it's very important for us to learn sign convention. I have explained sign convention step by step in another video, the link for which will also be there in the description below. Do check that out if you have not seen that. So starting with the sixth question, an object 5 centimeter high. So the object height is given as 5 centimeter. Placed at a distance of 60 centimeters. So the object distance is given as 60 centimeter in front of a concave mirror of focal length 10 centimeter. Find the position and size of the image. So I would be writing the given data. Height of the object is denoted by the letter O. So yeah, it is denoted by O. So it is always taken as positive. So it's going to be 5 centimeter. Object distance is given as 60 centimeters. So object distance is denoted by U. And it will always be negative by sign convention. So it's going to be minus 60 centimeter in front of a concave mirror of focal length. So focal length for concave mirror is taken as negative. So I would write F is equal to minus 10 centimeter. We need to find the position, that means we need to find V, and then we need to find the size, that means we need to find I. So we'll be using mirror formula first, that happens to be 1 by F is equal to 1 by V plus 1 by U. Now we need 1 by V, so 1 by U goes to the other side, so I get 1 divided by V is equal to 1 by F minus 1 by U. Now I would be substituting the values. 1 by F is going to be 1 by minus 10, which can be written as minus 1 by 10 minus of 1 by minus 60 can be written as minus 1 by 60. So here we have minus 1 by 10, minus into minus is plus 1 divided by 60. So the LCM of 10 and 60 is going to be 60. So here I write the LCM. So LCM is 60 and here 10 into 6. So here we get minus 6 plus 1. So we get it as minus 5 divided by 60. So minus 5 by 60 is 5 into 12 times. So here we get minus 1 divided by 12. So we have got 1 by V is equal to minus 1 by 12. Now we can write V is equal to minus 12 centimeters. So we can write image distance or the position of the image is 12 centimeter in front of the mirror. Now we know the formula for magnification. We need to find I. So magnification formula I write here, that is M is equal to I divided by O is equal to minus V divided by U. Now do we need to find magnification? We don't need to find magnification. So I can erase this part and we just need to find I. So it's definite that I will be equal to minus V divided by U into this O goes to the other side, so we multiply by O. We'll just substitute the values. Minus V will be minus of minus 12 because V is minus 12 divided by U is minus 60 into O is given as 5. Now we will be cancelling few things. Minus minus cancels here. 12 into 5 is 60 and 5 cancel. So we are just left with the minus sign. That means we have got the value of I as minus 1 centimeter. So we have got it as minus 1 centimeter. So we can write it as 1 centimeter, and since it is minus sign, it means 1 centimeter inverted. So we have got 1 centimeter inverted. So the question has not asked nature, but if you want to write the nature, nature is going to be real and inverted. So nature is real and inverted. And coming to the size of it, the size is diminished because we can see the object was 5 centimeter in height and the image is just 1 centimeter in height. So we can write it is diminished. So this was a simple problem, I would say, nothing tricky about it. Getting into the next problem, which happens to be the last problem for this video, question number 8 onwards will be solved in the next video, the link for which will be provided in the description below. Do check that out. So coming here, what is given is a point light source is kept in front of a convex mirror at a distance of 40 centimeters. So object distance is given as 40 centimeter. Focal length is given as again 40 centimeters. So object distance is also 40, focal length is also 40. We need to find the position of image. That means we need to find the value of V. So I would write the given data. U is 40 centimeter, but object distance is always negative according to sign convention. So we write it as minus 40 centimeter. Focal length, now it is given as convex mirror. That means focal length will be positive according to sign convention. So F, I would take it as plus 40 centimeter, and we need to find position of the image. That means we need to find the value of V. So what I do here is I would again use the mirror formula only. So that is 1 by F is equal to 1 by V plus 1 by U. Now we need to find V, so that means I can write 1 by V is equal to 1 by U goes to the other side. So 1 by F minus of 1 by U. Now we just substitute the values. 1 by F happens to be 1 by 40. So here I get 1 by 40 minus of 1 by U happens to be minus 1 divided by 40, and I would put brackets on both sides. 1 by 40 is nothing but minus 1 by 40. So minus into minus is plus. So what we get here is 1 by 40 plus 1 by 40. So I can write it as 1 divided by V is equal to, the LCM happens to be 40 and 40, LCM will definitely be 40 only. So LCM is 40, and what I get here is 1 plus 1 divided by 40. So 1 by V is equal to 2 divided by 40. So this cancels, so we get 20 here So we get 20. So 1 by V is 1 by 20. So V will be equal to plus 20 centimeter. So we can write regarding position 20 centimeter behind the mirror. So this is the position, since we have got V to be positive, and we can definitely tell it is a virtual and erect image. So this is not required, actually the question did not ask to write about nature. So this was a easy question, I would say. Next question onwards will be there in the next video. If you like the video, do share it with your friends and consider subscribing to the channel. So let's meet in the next video. Dhanyavad.